Welcome to the Center for Research Quality Basic Quantitative Research webinar. The learning objectives of this tutorial are to comprehend the process of deductive reasoning, differentiate between variables and constructs, differentiate between the scales of measurement. We'll then address the four pillars of quantitative research, which are theory, hypotheses, observation, and confirmation. Finally, we'll address the concepts of sampling and calculating sample size or power analysis in quantitative research. What is quantitative research? In a broad sense, quantitative research is a research method where the researcher employs deductive reasoning. That is, the researcher identifies a theory to examine a problem, formulates hypotheses regarding the theory, collects data using observation methods, and then conducts statistical analyses to confirm the theory. These four pillars, theory, hypothesis, observation, and confirmation, are the cornerstones of deductive reasoning. We will address each of the pillars in depth. Variables and constructs represent the basic currency in quantitative research, and there is a distinct difference between the two. Both variables and constructs are measurements holding at least two distinct values, and these values describe the item of interest. However, variables are directly observable measurements, whereas constructs are subjective measurements. Examples of variables include gender, age, education, and salary. I'm sure you can think of numerous other variables. On the other hand, constructs are not directly observable. That is, they are subjectively derived as the study participants provide a mental representation based on factors such as experience, feelings, and attitudes. Researchers observe constructs using a psychometrically sound instrument, normally in the form of a Likert scale. I'm sure most of us have completed a survey asking us to rate a subjective measurement on some continuum, say 1 to 5, where 1 represents a lesser subjective feeling and 5 represents more prominence of the subjective feeling. Regardless of a variable or construct being measured, each currency has a scale of measurement, which is critical to understanding basic quantitative research. A nominal scale of measurement is a categorical measurement such as gender, where there are two categories, male and female. Another example of a nominal scale of measurement is marriage, where the respondent can answer yes or no. I'm sure you can think of other nominal measures. The other three scales of measurement, ordinal, interval, and ratio, are numerical values but differ in the definition and their application in quantitative research. For example, a Likert scale is used to observe ordinal data. Please review the CRQ Scales of Measurement video tutorial for a more in-depth examination of the scales of measurement. The first pillar, theory, is the essence of quantitative research. Let's examine the role of theory in quantitative research. What is theory? A theory is used to explain a problem or phenomenon. The theory can consist of variables or constructs that we just discussed that allow the researcher a systematic view of the problem. A feature of the theory is that it must be falsifiable. Falsifiability is the capacity for some proposition, statement, theory, or hypothesis to be proven wrong. The concept of falsifiability was introduced by the philosopher of science Karl Popper. Popper proposed that statements and theories that are not falsifiable are unscientific. Declaring an unfalsifiable theory to be scientific would then be pseudoscience. More so, the theory drives the observation, which I will discuss later. Please be sure to review the role of theory in quantitative research video tutorial for further detail. Let's examine a theory, the job demand job resources model. Researchers can use the job demand model to view a problem such as job satisfaction from the perspective of two domains. The first domain being job demands and the second being job resources. As you can see, constructs are embedded in the theory. Recall, we previously addressed constructs. Several constructs underlie each domain. However, I have highlighted a few in blue that will be used to explain other concepts in this webinar. For example, emotionally demanding interactions fall under the demands domain, and autonomy and coworker support fall under the resources domain. The construct highlighted in red, job satisfaction, reflect the problem or topic of interest. Job satisfaction would then be the dependent variable. What is very important to understand is that theoretical constructs represent the independent or predictor variables. Job satisfaction is the dependent or outcome variable. I will elaborate on this important concept very shortly. However, the major takeaway is that the independent or predictive variables are extracted from the theory. This is very critical to remember as we proceed. Let's now examine the second pillar of quantitative research, the hypotheses, where we test the theory. So exactly what are hypotheses? Hypotheses are educated guesses derived from the literature about the nature of the relationship or problem you are investigating. Let's use the job demands job resources model as an example for formulating hypotheses. For example, a researcher might hypothesize that emotionally demanding interactions, which is a job demand, and autonomy and coworker support, which are job resources, can predict job satisfaction. So you can see the relationship between theory and hypotheses. Again, the constructs identified in the hypotheses must be derived from the theory. This is a very important concept to remember. As we examine the research question and hypotheses, we can see that the null hypothesis is always the hypothesis of no difference or no relationship. The research, in most instances, seeks to falsify the null hypothesis and find supporting evidence for the alternative hypothesis, which again is the hypothesis that the researcher will find the relationship if it truly exists in the population. In other words, the theoretical constructs underlying the jobs demand, jobs resources model can be used to explain or predict job satisfaction, which again, in this case, is the problem variable. We'll now examine the third pillar of quantitative research, observation. Observation involves measuring or assigning numerical properties to the variables or constructs of interest. The variables or constructs are either independent or dependent. Recall, the independent or predictive variables are derived from the theory. The dependent variable or construct is the problem of interest, again, which must be defined in the problem statement. I have selected an instrument titled the Work Environment Scale. The Work Environment Scale can be used to observe or measure the constructs underlying the jobs demand, jobs resources model. Therefore, the researcher must use an instrument that will measure the variables or constructs underlying the theory. Recall, I indicated the theory drives the measurement. Note, the constructs in blue are the constructs identified in the jobs demand job resources model. Another example would be a researcher using the multifaceted leadership questionnaire to measure transformational leadership constructs. The MLQ is the benchmark instrument used to measure transformational leadership constructs. You can now see the relationship between theory and observation. The researcher must use a pre-established instrument, one with sound psychometric properties. The instrument must possess adequate reliability and validity. Reliability refers to the instrument yielding consistent results over time. Validity refers to the instrument measuring what it is purported to measure. In other words, an instrument purporting to measure job satisfaction must in fact measure job satisfaction and not a similar construct such as job commitment. Finally, the researcher must never develop their own questions to measure any construct. This is a cardinal sin in quantitative research, unless the objective of the research is to create an instrument. Let's now discuss the critical concepts of sampling. Oftentimes, the researcher has a sampling frame and chooses to use the entire frame. A sampling frame can be a listing of participants or cases. For example, a census is conducted if the researcher uses the entire sampling frame. Think about the U.S. Census conducted every decade. The goal is to collect data from every household in America. However, sampling is more commonly used in research. Probabilistic or random sampling and non-probabilistic or non-random sampling are two broad sampling typologies, each with its advantages and disadvantages. Please be sure to review the sampling video tutorial for further detail. Sample size is critical to quantitative research and is another combatant to statistical conclusion validity. As such, researchers must conduct a power analysis or sample size calculation to determine the minimum required sample size for the research scenario. Two common approaches are the use of G-Power 3 software and or using a formula by Tabachnik and Fidel. G-Power 3 can be downloaded for free from the internet. Simply Google on G-Power and you will be taken to the website. The formula method is 50 plus 8 times m, where m equals the number of predictive variables. Note, this formula is only appropriate for multiple linear regression. You will need to use, for example, G-Power to calculate appropriate sample sizes for other statistical tests such as t-tests, ANOVAs, etc. The important point to remember is that you must conduct a power analysis regardless of the type of analysis you are doing. The fourth pillar, confirmation, involves testing the theory using inferential statistical analysis. Understanding the alpha level, significance, and effect size are critical to the confirmation process. The alpha level is the probability of falsely rejecting the null hypothesis. The alpha level is set at 0.05, meaning the researcher has set a tolerance of 5% chance of falsely rejecting that null hypothesis. The alpha level is set prior to running the analysis. The significance level is the weight of evidence against the theory. The significance level is compared to the alpha level. A p-value or significance value less than or equal to 0.05 means the null hypothesis is rejected and the alternative hypothesis is accepted. In other words, the researcher has found supporting evidence that the predictive variables, again, which were derived from the theory, are successful in predicting the dependent or problem variable. Finally, the effect size identifies how strong the relationship is in terms of variance explained in the dependent variable. Many researchers make the mistake of only interpreting and reporting the p-value. Be sure to interpret the strength of the relationship using the effect size and always report the effect size in your finding. Also, you will note that effect sizes vary by statistical tests. For example, R square is used in multiple regression, Cohen's D is used in the t-test, ETA squared is used for ANOVAs, etc. This slide depicts an example SPSS output for a multiple linear regression analysis. Note the p-value of 0.003 indicates a significant finding as the value is less than 0.05. Thus, the researcher has confirmed the theory. In this brief video tutorial, I discussed the process of deductive reasoning, differentiated between variables and constructs, differentiated between the scales of measurement, discussed the four pillars of deductive reasoning to include theory, hypotheses, observation, and confirmation. And I also discussed the concepts of statistical power and sample size calculation. Thank you for reviewing this video tutorial, and please be sure to take advantage of the CRQ series of capstone resources to aid in your success. We wish you the best moving forward. Thank you.